Time, love, technology, curiosity, real art, mathematics, science. The world is ready for the next really necessary product.
Hi, I'm Isa Gutierrez, CEO of BioLife, a company in charge of making a better future with alternative ways to produce energy.
Hi, I'm Manuel Gonzalez, founder of BioLife. Have you ever wondered why humans depend on fossil fuels and want to do something to change it? Well, we do. Here at BioLife, we really believe in the development of tools to reduce the dependence that humans have on fossil fuels and experience a transition to renewable energies. We are so excited to announce our newest product, the Biodigestor. A Biodigestor is a hermetically sealed container in which enter manure, food waste, and organic matter. Inside, an anaerobic biodigestion process is carried out. During this process, effluents, organic waste, and water are transformed into a biofertilizer known as bio, a soil improver that contributes to a higher crop yield. Moreover, a natural gas rich in methane called biogas is produced, which can be used as energy for cooking, heating water, and as fuel for electric or mechanical power engines. The bacteria convert manure, vegetable matter, and organic waste into methane gas. It is a mixture of gases that is produced as a result of the fermentation of organic matter in anaerobic conditions by microbial decomposition. With this, we intend to solve the energy problem of heat generation. Our aim is to reduce LP gas consumption and the dependence that human beings have on oil. Our project focuses exclusively on the generation of biogas for domestic use. Let's talk about the features.
The type of biodigester that we are planning to do is a tubular series prototype made of HDPE, high-density polyethylene, thanks to its corrosion resistance, supported by a wooden base.
The biodigester is built with the following characteristics: 6 5-gallon drums of 0.54 meters diameter and an average height of 0.9 meters. The volume of each container is 208.197 liters for a total volume of the biodigester of 1,249.182 liters, which is 1.3 meters elevated to 3. The biodigester was provided with a pipe system on the top which contains the biogas. At the bottom, it has another pipe system interconnected for the distribution of stabilized biomass. Here occurs the anaerobic digestion. Is a process complex in the anaerobic cycle of carbon, in the absence of oxygen, transform the organic substance into biomass.
Hi, I'm Oscar, and I'm going to explain the anaerobic digestion from natural polymers and in the absence of inorganic compounds. This process is divided in 3 stages. The first one is hydrolysis and fermentation, in which organic matter is decomposed by a group of anaerobic hydrolytic bacteria which transform fats, proteins, and carbohydrates into simple compounds and monomers. The second stage of the process is acetogenesis and dehydrogenation. In this stage, alcohols, fatty acids, and aromatic compounds are decomposed, producing acetic acid. Also, CO2 and hydrogen are substrates of the process. The final stage is the methane production, in which CO2 and hydrogen, by effect of methanogenic bacteria, produce methane.
Microorganisms that intervene in the process are hydrolytic and fermenting bacteria, hydrogen proton reducing acetonogenic bacteria, reducing sulfate bacteria, acetonogenic bacteria, methanogenic bacteria, and the nitrifying bacteria.
In order to ensure the biological cycle of the bacteria anaerobic digestion process, the following conditions must be presented in optimal conditions.
The first one is temperature. Mesophilic bacteria complete their biological cycle between 15 Celsius degrees to 40 Celsius degrees with an optimal temperature of 35 Celsius degrees. Thermophilic bacteria fulfill their functions between the 35 Celsius degrees to 60 Celsius degrees with an optimal temperature of 55 Celsius degrees. The second is hermetism. To carry out efficiently the digestion process, the fermentation tank must be hermetically sealed. The third condition is the pressure. The subatmospheric pressure of 6 centimeters of water inside the biodigester is the optimal pressure. And the fourth is holding time. That is the average time that the organic matter is decomposed by the bacteria. It has been observed that a short holding time is better to produce a great amount of biogas.
The following condition is a nitrogen-carbon ratio. It must be 30 carbons for every nitrogen. If not, if the ratio is very narrow, such as 10 carbons by every nitrogen, then it could lose the quality of the biogas. The following condition is the percentage of solids, which must go from 7 to 9%, and you can achieve it by diluting the mixture with water. And the following condition is the pH, which must go from 6.5 to 8. However, in order for it to function in optimal conditions, it should be from 6.7 to 7.5 in the pH scale.
However, the amount of biogas that we are capable of producing depends on the species of animals that we use and the capacity of our digester. So in order to calculate the specific quantity of biogas that we can produce per day, we need a set of formulas that will tell us the information we need. Considering the measurements of our digester, a burner that consumes 1,400 liters of gas, and that we would use pig's manure, the results are the following. The pig's manure has an average of 450 liters per kilogram, and the average activity of a pig in a farm is of 17 hours per day. So taking that into account and applying the formulas, we realize that we need a total of 26 kilograms of manure and 11 pigs to produce enough biogas for a day. It is important to consider that you will need to multiply the amount of manure by 1.5 in order to get the amount of water that you need in the digester. In this case, we needed 39 liters of water.
I'm Manuel Gonzalez, founder of BioLife. Thank you for watching. BioLife, making an effort to save the world, the planet, our home.